Thank you for joining us this morning or afternoon, hopefully not night, for this month's webinar. This month's session in Practice Guest Webinar Series. Today we have the honor of hosting Federico Toledo in a session about optimizing performance testing and unveiling the performance testing pyramid. Before I hand over to Fede, I'd like to share a little bit about us, about Practice, in case you're not familiar with who we are. So Practice is an end-to-end enterprise-grade test management platform powered by QA intelligence and AI. Essentially, we are a centralized testing hub that's connecting anything related to testing, from requirements, testing execution and issues, and visualize the results so you can make better quality-related decisions. As I mentioned, we are an end-to-end platform, so all the way from, and regardless of the way that you are working. Some of our customers, we've been around since 2008, so some of our customers are still using waterfall. Sounds very weird for performance testing, but we do know this exists, and we have assisted them in their migration. Through, of course, the majority of customers who use Agile or DevOps, the system is extremely flexible and scalable. So regardless of the way that you work, you can start using Practice all the way from getting in requirements and modules, core executing of testing, whether it's manual, scripted, exploratory, or automated, that's connecting the results to the platform, finding issues, hopefully but we know those exist, and then visualize those results so you can make better decisions. That's a little bit about what we do. Among our customers, you can find some very nice logos. I assume you know some of them across pretty much any industry. For testing professionals, I don't need to say that any company needs testing, but whenever I present it to others, it's sometimes surprising to hear, why would a hospital, a fast food chain, or anything which is not a pure traditional software company would need testing? But the answer is because it does. So you can see that among our customer base, and this is something we take a lot of pride of, from basically any industry from across the globe. We currently have customers in more than 55 countries around the world. So that's a little bit about a customer base. We run a live training and Q&A session that you are more than welcome to join in case you don't want to commit and you just want to come and see it yourself. Additionally, of course, if you prefer, you're more than welcome to reach out to us, and then we'll schedule a dedicated session for yourself. And one last thing that I want to say before handing off to Federico, some housekeeping for this session today. The session, as I mentioned, is being recorded. We will share the recording with everyone who is here, also people who have signed up but are not able to join us live due to time gap. As we discussed throughout the session, you feel free to write questions on the chat, on the Q&A, and then Federico will hopefully respond to them on a timely manner. And without further ado, handing over to you.
Excellent. Thank you so much. I will share my screen. Can you see the slides? Yeah, perfect. Well, first of all, thank you for the opportunity of doing this collaboration. For me, Practice is one of these companies that generates lots of content and help the community in different ways. So I'm really happy to start this partnership and to collaborate today with this talk. That, as Noah mentioned, the title is Optimizing Performance Testing. I'm going to present a pyramid for performance testing, which is inspired, of course, in the famous, or for some infamous, test automation pyramid. Well, before I start with that, let me tell you a little bit more about myself. I've been almost 20 years in software testing. I'm one of the co-founders of Abstracta, fully dedicated to software quality and innovation. We have different products, and we also typically share content and try to help generate communities around the practice of software testing and quality. And one thing I wanted to highlight is a couple of conferences that I'm organizing this year. One is the WOP, or the most prestigious workshop on performance and reliability. Last year, we started the branch for LATAM, specifically in Spanish, and it was in Chile. This year, we are organizing it in October in Medellin, in Colombia. So if you are a Spanish speaker and you can make it to Medellin in October and want to participate and share experiences with another 20-25 performance testing experts, I really recommend to apply. It's completely free, and the call for participants is open until June the 2nd. And also in the same week, we organized the Quality Sense Conf in order to bring those experts into the stage of broader audience, so we can also share with the local community in Medellin. We are also looking for sponsors and for speakers. PractiTest is one of our sponsors for this year event. So the agenda for today, I will start with some introductory topics. Then I will explain the testing pyramid, the model layer by layer. We will close with some thoughts and the Q&A at the end. If you have any questions, please questions, comments, add them into the chat. So as an introduction, as I mentioned before, this pyramid, this model I will share today is inspired in the test automation pyramid that was coined by Mike Cohn in 2009 in his book, Succeeding with Agile. That was the first time he mentioned and explained this model. And then after that, many people started to use it and explain how to approach test automation efforts following this model. Basically, if you never heard of it, well, that will be a problem. You should have heard about the test automation pyramid. But basically what it says is that we should group test cases, test automation in different granularity by layer, like user interface, service layer, API, and unit tests. And the shape of the pyramid, basically what it's telling you is where you should put most of your efforts in order to get the different ROI, okay? So if you really want to know more about this approach, I would strongly recommend to read this article from Martin Fowler that he explains it in a more practical way with different tools, also paying attention to more modern approaches like how to use this in continuous integration, continuous delivery. So this is a great article to have more knowledge for test automation following this pyramid, okay? Some other ideas that I think are important in order to understand what I'm going to present later for performance is that the automation pyramid also inspired another way of presenting it in another model, which is the ICE-CON pattern, which is what most people follow. Because most of the people, when they do test automation, they pay more attention to the UI level using Selenium, Playwright, Cypress, a tool like that, in order to automate the test cases similar to a user executing a test case. And this is actually an anti-pattern. This is not the best way to put your efforts in test automation. What also the pyramid is telling you is that if you go down in the pyramid, you will get more isolation, which is something that we want in the test cases to be able to run them independently. The feedback that you are going to get is going to be faster and easier to act on because it's specific on a specific unit, right? So it's going to be easier to understand where a specific test case is failing, right, and repair it. The test cases are going to be more easier to maintain. And this approach can help you to do shift-left testing, to start earlier with the test automation activities in your testing process. And if you go up in the pyramid, you will have a closer look at the user experience because we cannot only test the units, even though they are more efficient and so on, but we also need to complement this to also do test automation in the different layers in order to gain more perspective on the user experience. We also will see how the different components interact with each other. We will have more integration, though that adds more complexity in the test cases in the test environment, of course. So That's all for now about the pyramid, the original model. Another topic I wanted to talk about as part of the introduction is how the performance test automation works, because it's very different to the functional test automation. With the tools like Playwright, Cypress, Selenium, what typically these tools, what they do is to manage the browser. So the test automation actually interacts with the application through the UI. So they locate elements like a button and they click the element in order to interact with the application. When we do performance testing, what we want to do typically is to simulate thousands of users accessing to your system. And we cannot do a simulation with thousands of browsers because it would require a lot of machines in order to run that type of test. So this is why tools like JMeter, which is one of the most popular open source solution for performance testing, what they do is to try to simulate the users, the virtual users, as we call them, at the protocol level. So when we run the simulation, if we want to simulate 1,000 users, JMeter, what it's going to do is to open 1,000 threads and connect each thread with the server and send HTTP request, which is more efficient in order to do that simulation. In my laptop, I would say that I could run a test with JMeter around 1,000 users, more or less. It depends on the script, but I would say that 1,000 users is what I can run with one single laptop. If you want to run a simulation of 20,000 or 100,000, the typical approach of the modern tools is to prepare the script locally with a tool like JMeter, and then upload that script to the cloud to different tools like Gatling, BlazeMeter, Octoperf, K6, there are many more, but they all do the same type of approach, like having an open source solution here to work locally to prepare the script, and then upload that script to the cloud, and they charge you by the use, the number of uses you run and for how long you run them. So this is basically how the test automation works and for performance. And then another part of the introduction I wanted to give you is how the traditional load testing activities are done. And it's pretty waterfall. What we do, actually, we call them performance testing projects. And it takes like between 1, 2, 3 months, more or less. And we typically plan to do these activities for a specific release or for a migration, changing the technology, the platform, or something like that, or because we are preparing the system for Black Friday or some specific event. 3 phases, more or less. The first one, it takes around a week to gather all the information, define the goals, the acceptance criteria, what's the test strategy, defining the tools, the scenarios, the different test cases, all of that. It's at least a week in order to also to align all the stakeholders, right, and document what's needed. Then the most expensive phase is the automation phase, which I say it takes 80% of the project duration. And here is where you prepare the test automation at the protocol level, which is actually harder than preparing a Selenium script, for example, because you really need to understand the protocol. And HTTP probably is the most common one and the simplest one, but your application may be using WebSockets or any other protocol. So preparing those scripts can be hard. And you also prepare the monitoring tools and other tools that you might need during the execution, which is the last phase. And actually, this last phase is the one that gives you value, because you run the tests, the simulation, and you analyze the system, you find the bottlenecks, improve, and run again. And that takes a week, maybe 2. And you know, it's like the whole project to get 1 week of value improving the system. So this is the traditional approach, and this is why also I want to propose something different that combines some more modern activities or more modern approach to the performance testing, complementing this traditional way of doing it. And this is why we came up with this model of the performance testing pyramid, and I will explain it layer by layer. Basically, what I did was to map different performance testing activities with the original test automation pyramid. For what we just saw in the previous slide was the end-to-end performance test, which is doing the simulation, the performance testing project. A part of this, I would say that this should be the smaller portion of the testing, right? And our efforts should be put in different layers, like in the unit layer and in the service integration layer that I will explain in a bit. And also on the top of this, as some of the people also included the manual and exploratory testing to the pyramid, I will include here the analysis on the client side using different tools that we will see later on also in the presentation. Why this combination of strategies is important? Well, because the end-to-end tests are not suitable for continuous integration and continuous delivery. They are very expensive, they are slow, and the learning cycles are really long. So this is why we need to do some other activities apart from the end-to-end performance test. So here you can see the ideal performance testing pyramid, right? And what I will comment here is similarly to the test automation. When you go down in the pyramid, the tests are cheaper, the results, you can get them earlier, so the learning cycles are shorter. You can run the test more frequently because they are also faster, which is better for continuous integration, right? And the problem with this, or the limitation, is that you won't have any idea of the user experience, which in many cases is the main goal of the performance test. So this is why we also need to consider the layers in the top that helps you to understand the user experience, because this is what we are going to measure, like the response times and the use of the infrastructure. And all the tests are going to be centered around the user and the way the user uses the system, right? Though they are more costly in preparing the scripts and in the infrastructure that is required. Let's start with the unit performance testing layer. What I'm referring here to as a unit is one single and isolated endpoint, right, at the API layer, at the service layer. So the proposal here is to have small load simulations for each endpoint, or at least for the most critical ones. And the goal is going to be different than the typical and the traditional load simulation. We are not trying to simulate the load that we are going to have in production. Instead, what we are going to try to do is to detect a degradation in the response time of that particular endpoint as soon as possible. So we are going to add in our continuous integration pipeline a small fixed load that is going to run every day after every pull request or something like that. And we are going to compare how the times evolve over time in order to detect a degradation as soon as possible, right? In some cases, in order to isolate the endpoint, we will need to implement some mocks or use some service virtualization. An important comment here is that the mocks shouldn't be the bottleneck. So we need to be careful when implementing mocks that they must be performant. And another consideration that is really important is that the scripts for performance testing at this layer in particular must be easy to maintain. Because again, we are going to be running these scripts every day at least. the traditional approach, when we prepare the scripts, we were trying to simplify the way we prepare them. So we didn't pay attention to the maintainability or the how we modularize the test or anything, because after the project finished, we typically discard the test cases. And here we are going to be using the same test cases every day. So maintainability is very important. This is why I'm not suggesting to use, actually, I'm suggesting not to use JMeter for this type of testing, because again, JMeter for me is the best tool for performance testing, the best open source solution for performance testing. But the issue is that when you prepare the test scripts, you use a graphic user interface, and it has a model representation, let's say a low-code approach, and the scripts are stored in an XML that is very difficult to compare one version with another in order to understand the changes. So it's not CI friendly, right? This is a way to put it. So the best tools for this type of tests are the ones that you can code your scripts. For example, Gatling, K6, and Taurus. And I will strongly recommend to take a look at the JMeter Java DSL, which is a wrapper of JMeter in Java in particular that we developed, and it's open source. It's going to be more integrated in the IDE, so it's going to be easier for developers to collaborate. If you are already having the repository, the test automation, you can add the test automation for performance in the same repository. So it has a lot of advantages, and if you know how to code, you are going to be much faster preparing the scripts. It's free to use because it's open source, so I really recommend to take a look at this one. And we are now also implementing a version for .NET, right? So one thing, Gatling is in Scala, K6 it's in JavaScript, and Taurus is like a YAML format. I would recommend to use the same language that you are using, the same tools and the same developer IDEs in order to have everything in the same place, and it's easier to collaborate with the rest of the team. One more thing related to the unit performance testing, as I mentioned before, the idea is to detect the degradations as soon as possible, and you will have this test running in your Jenkins every day, right? One problem that we can see here in this graph is that, for instance, this endpoint started responding in 100 milliseconds, right? And after some changes, it started to respond in more than 200 milliseconds. And after a while, more changes, and the response times were more in the closer to 400 milliseconds. And nobody got notified because the assertion, the green line here, was set in 500 milliseconds. So my recommendation here is that you need to be mindful about how to set the assertions in order to break the bill every time there is a degradation, so you get a proper notification and can work on it. And maybe you are wondering, how much load should I configure for these specific small simulations for each endpoint? And there is an experiment that you can do in order to define that load, which you can see in this graph. Basically, what I would recommend is to use, well, the testing infrastructure probably is a scaled down version of your production infrastructure. It's going to be smaller, right? So my recommendation is try to find a number of threads that when you run the specific test of this endpoint, you get closer to the saturation point. And this you can see in the violet line here, like how you find the knee of the graph, which means that the saturation point is around here. So I will set the test to simulate this number of threads, because in this way, I know that the system is almost stressed. It's close to the saturation point. And if there is a degradation in the endpoint, probably I will really notice very easy. So this is the way, one possible way of defining the load of every small test case at the unit level. If we move to the following layer, the integration layer, The important part here is we shouldn't believe that because we tested the different units, then the whole system is going to be performing correctly, right? This is the fallacy of composition. So the idea here for this layer is to add at least a few test scenarios where you are combining some endpoints that and the intelligent choice here is to try to combine those that you know that they have access to the same shared resource, the same tables of the database, the same files, something like that, in order to see how they interact and affect each other, right? So for this layer, this is the only comment. And then for the end-to-end performance test that I already explained a lot at the beginning when talking about the traditional approach to performance testing. But something to add to that is that the goal here is to mitigate the performance risks, right? And focusing on the user experience, the response time, and also the resource consumption of the different servers in the backend mainly, right? What we typically do to define this type of test simulations is the load itself, how many test cases, the number of concurrent users, and the scenarios, which basically is how many virtual users I'm going to be running for each test case, right? My recommendation here is try to select the most critical test cases. Don't try to cover all the system, because the more test cases you add, the more expensive your test is going to be, right? You also need test data, and here the important thing is to have the same volume and distribution of the data that you will have in production, so you can find all the issues related to the data access in your test. The infrastructure should be similar to production because it's difficult to compare different things that are different. You cannot correlate what's happening in an environment which is different from the one that your users are going to be using. So that's why in many cases people tend to use the production environment for this type of test. You can do that before the release, before the environment is being used, or you can run the test during the night or something like that in order to mitigate the risk of affecting the real users of your system, right? You need to use monitoring tools or observability tools. And my recommendation here is to use the same tools, the same metrics, the same KPIs, the same dashboards that you are going to have in production, because in that way you can see how the monitoring tools impact the performance. And also your team is going to learn how to deal with the performance issues using the tools that they are going to have once in production. So this is the best approach for that. And we also need to define the execution plan. In our case, what we typically do is define a baseline, which is a very small load in order to have the best response times of your system, and use that as a baseline, as a comparison to the following tests. And another recommendation here is don't try to run the complete load scenario at the beginning. Try to start with 20% of the expected load. Iterate there, like analyze, find the bottlenecks, improve the system, and after you find you get the system working as you want, then move to 50% of the load, and then to the whole load simulation. This is important in order to attack the issues one by one and not all at the same time, which might be messy and difficult to do. And if you remember, in the top of the pyramid, we also have the client-side performance, which basically for web applications is analyzing how the web browser is dealing with the web page and loading the web page. There are a lot of tools that help you to do an automatic analysis. The easiest for me is using Lighthouse, which is part of the Chrome developer tools. And what you can get is a report like this just by clicking do the report. And you can get some metrics, not only for performance, also for accessibility, some best practices and SEO recommendations. You get a lot of metrics and the issues with a link to how to solve them. So this is a good tool also to learn more about the performance issues, the status of the performance of your web page, and also to find solutions. For mobile applications, for native mobile applications, I would recommend to take a look at AppTeam, which is also a tool that we implemented. And it has a free version that helps you get a report very similar to this one, but for mobile native applications, okay? And even though this approach is not included in the pyramid, this idea of the hybrid approach is basically another way of doing the end-to-end performance tests, which is simulating the backend at the protocol level, thousands of users from the cloud, etc., and then having a few test cases running with Selenium or Playwright. So you also have the metrics of the client side, right? And the response times of the whole user flow, even considering the client side. So this combination could be, this hybrid approach could be a way of running your end-to-end test cases, test simulations in a better way in order to have metrics from the backend and from the frontend as well. Well, some closing thoughts. This approach, this pyramid, this strategy is also helpful for following the idea of shift left performance testing, which for me is not shifting, it's more about expanding, because you don't want to stop doing performance testing here and start doing in the left of the process, right? You want to also include activities earlier in the process. And when we talk about shifting right, also expanding right is like also doing performance tests more in the right of your process. When we do earlier testing, like at the unit level, at the service level, we can do this idea of shifting to the left. And for shifting to the right, there are different strategies like chaos engineering, carrier releases, and more other things. But the one I wanted to highlight is observability. Jennifer Sanchez, one of the people that we are collaborating in organizing the Whopper this year in Colombia, said this thing last year in the Whopper last year. Observability is the new performance testing, and I really believe that I've seen that many performance testers now are working in observability as a way to solve the same issue. For me, it's also like another thing to do. It's really important to have a good observability and monitoring system to control what's happening in production. And maybe to wrap up the presentation, I want to give you this advice on how to optimize your performance budget. If you have limited budget, make sure that your observability is working well, is working. I mean, that you have the tools, you have the proper configuration, that your team is trained, that your team, not only your SREs and your developers, they know how to access Dynatrace, Datadog, or whatever tool you have. But also your testers, your analysts, business analysts, and everyone can learn about how the users are behaving in production in order to improve the system. And after you have observability in place, you can optimize your performance testing approaches and efforts following the model of the pyramid that today I presented. I hope you find this approach useful, and I'm really looking forward to continue the discussion with you if you have any questions. And today or at any moment, I also would like to continue the conversation with you on LinkedIn. Is the place where you can find me, and typically I'm sharing content over there.
Thank you. We have several comments and questions that I'd like to start. One which was sent privately is about, you almost can't skip this question, is about the relationship between performance testing and AI, which everyone now insists on talking, and showing how are you using AI, where are you using AI?
Yeah, absolutely. And I've been researching a lot about the intersection of software testing and software quality and artificial intelligence, not only to think which are the prompts that can help me design test cases or whatever, but also to understand how to test this type of systems. Because it's true that there are many tools. You also mentioned that now Practice is integrating some of the new terminology in order to provide better features to the users, right? And I think all the tools around performance, they are also doing the same. Also, the observability tools, they are giving you assistance where you can chat with the monitoring tool in order to analyze the bottlenecks. For example, this is one line, but one thing that I believe that we need more research is like how to guarantee the performance of the applications that are going to be using LLMs or artificial intelligence, because there are many challenges, and not only challenges. If you're familiar with ChatGPT, Gemini, or something like that, we changed our perception and our expectations about the performance. Because if you think about what's happening in the backend, it's like, I'm talking with a large language model that is inferring content, blah, blah, blah. So if you asked me 2 years ago, what's your expectation about the response time of such a system? I can wait 30 seconds, a minute to get this type of content. And today is like, no, it must be immediate. At least this flow of conversation is like generating the test word after word. So they are redefining the way we conceive the performance and the expectations we have. So as this is the way the artificial intelligence systems behave now, if I'm going to implement something like that, my users are going to have that type of expectations. So I need to provide this performance. So for me, that's the challenge that we professionals working in performance have nowadays. And for sure, the observability tools, they are going to help us a lot. And we will need to do. Say again, sorry.
And they will have to adapt to.
Yeah, for sure.
Great. Thank you. And now, of course, as always, there's more. Now, interesting one. Actually, we're going to have a shared webinar that answers some of this, but I will lend the question to you. The question is about strategy of performance testing when production environment and non-production environment are built differently. Okay, we know that, testing environment is a challenge for many of our customers. This is something they were here. And then the question is, would you limit performance testing only to production because they're not the same, or it doesn't have an ROI in this scenario, testing the non-production?
Yeah, I think I mentioned a couple of things related to that during the presentation. One thing is that, of course, if I cannot run the expected load or a similar load that the one in production in the testing infrastructure if it's smaller, because I'm going to have a negative result and maybe the system is performing well in production. So it's difficult to extrapolate the results from one system to another. That doesn't mean that you shouldn't run the performance test, because you can anticipate 2 different issues that you may have in the system. But if you work in your testing environment and you have the system like optimized, working perfectly, that doesn't mean that in production with the expected load is going to perform well. So the difference between the production environment and the testing environment, that gap is the risk. So the question is what you can do in order to mitigate that risk, in order to mitigate this gap. One thing is understanding this gap. Okay, less memory or less number of servers or whatever. So what can I do in order to know that in a different environment with a different number of servers, the system is going to scale properly, right? So this type of thoughts, I think we need to have. And another thing is that for this type of unit performance tests, it's better. Actually, it's better to have a smaller infrastructure because it's easier to get to this saturation point that I was talking to, and the goal is different. It's not to guarantee that the user experience is going to be good, but is to detect degradations as soon as possible. So there are many things that you can do, even though you don't have the resources of production for your testing efforts, right?
Right, thank you. And the last question, which I hope I'm getting right, but maybe you'll do better for me. You've mentioned that in which ways does not automating performance testing affect the CI/CD testing? Is a main factor. How does it stop the cycle? I think that's the main question about it.
Yeah, it's a very good question because even though you have small simulations, it will take time. And something that you want from your build is that to be quick in order to have quick feedback. There are different strategies to follow here. One is to have a reduced number of performance tests for the most critical, let's say, to the top 5 endpoints, and include that only in your build. And then have another pipeline that runs every night or in parallel or something like that, every hour, whatever, with the full regression testing for performance, right? This is the easiest strategy in order not to affect too much the build and also have updated information and detect the degradations as soon as possible. I hope that answers the question.
That's I hope so as well. But if there's a follow-up, and then I would put the last question, and one, actually there are two. One I think you'll answer, and the other one I invite you to, I assume you have it written somewhere. One is related to the topics they talked about, difference between production and testing environment, and it mentioned they're not limited to capacity and resource, and often there are functional areas that are different, like third-party integrations for payment processing that you don't have control. And then how would you approach those issues in the context of performance testing?
Well, I mentioned preparing mocks and using service virtualization. This is the solution for that. I mean, you shouldn't use the credit card or whatever your system is connected to. But again, there is a risk because there is a gap between your testing and your production environment. So you need to manage that risk. Because last year, there was an experience report in the Whopper, someone that explained a whole performance test during 6 months. They were working a lot, they prepared everything, they improved the system. And when they went to production, there was a third party that failed and everything was a mess and working horrible, So because they said, okay, this component is going to be working fine because there is an SLA, right? Okay, they needed to execute that SLA because
I think any tester, anyone with some experience in testing can relate to that feeling when you should be testing better, but business is pressuring. So you're just saying, okay, this time it's going to be okay because we tested very similarly in XYZ, but then it comes trouble and.
Yeah. I mean, to be aware of to be conscious about your limitations, about those gaps between the different environments, and try to have a plan for how to mitigate those risks as well.
Perfect. Thank you so much. Before I close, I will tease that one of our future webinars is indeed going to deal exactly with this challenge, not so much about testing environment and testing data, which is hard to obtain sometimes when performing tests. So we are partnering with another company to share a webinar about this. We will promote it soon and all of you will be invited. Federico, I want to thank you for this session. It was very interesting, and I can tell you from hosting many of those, it's very engaging. People were asking many questions, so you can see that this is on topic. That's relevant for many people. So thank you for being with us. Thank you all for attending. As I mentioned, we will share the recording and have a good rest of the day.